Alright, today we're going to start talking about polynomials. To do this, we first need to understand what is a monomial. So, let's break that word apart. Monomial means one part number. It can be a variable or a product of numbers and variables. Whole number, exponents. I'm going to write down some examples of monomials and things that are not monomials. So let's make ourselves a little t-chart. We can have monomial on one side, and on the other side, not monomials. So, examples of monomials. We could have just the number 5. We can have just the letter x. We could have negative 7x, y. We could have 0.5 x to the power of 4. Those are all examples of monomials. Some non-examples, examples that are not monomials, we could have 0.3 x and the power is negative. If we had an expression like 4x minus y, that is not a monomial. Or if we have something like 2 divided by x to the power of 3, that's not a monomial. We're going to look at the word degree of a monomial. The degree of a monomial is the sum of the exponents of the variables. And then if we have a constant, the degree is always 0. Constant meaning if it is just a number. If we do not have any variables, then the degree is 0. So let's now look at our first actual example. What we're going to do is find the degree of the monomial. So example 1, find the degree of each monomial. With our first problem, example 1a, we're going to have negative 2a to the power of 2, b to the power of 4. So what we're going to do to find the degree is we're going to look at the powers of both variables and add them. So in this problem, the degree is 6 because 2 plus 4 is 6. If we have the number 4, then this one is pretty simple. There are no variables, so we say the degree is 0. When there's no variables, we just say the degree is 0. And lastly, we have 8y. Now, technically, there is a power to that y. That power is a 1. So in this case, we're going to say the degree is 1. And we are done with our first example. So now we're going to define another word. This next word is polynomial, meaning many parts. So what we can also say about it is it's a monomial or it can also be a sum or difference of monomials. So it could be many monomials put together with addition or subtraction, or it can just be a single monomial. The degree of a polynomial is found by taking the degree of every term and finding which term has the highest degree. So it is the degree of the term with the greatest degree. And that might seem kind of odd, but let's look at some examples. So this is example 2. We are going to find the degree of each polynomial. So our first one we're going to do in example 2, A here, we're going to have 4x minus 18x to the 5th. So we need to look at each term. We've got the 4x term, which has a degree of 1. And then we have the minus 18x to the 5th, which has a degree of 5. So since 18x to the 5th has a higher degree, we say that the degree of the polynomial is 5. Let's look at least one more. So 2b. We're going to look at 0.5 x squared y plus 0.25 xy plus 0.75. So our degree of our first term, 0.5 x squared y, that degree, which I'm going to just write deg for degree, is 3. 0.25 xy has a degree of 2, and 0.75 has a degree of 0. So the degree of the polynomial is 3, because that is the higher of the degrees. The first of our next terms is going to be standard form of a polynomial. The standard form of a polynomial, what we do is we write the terms from highest degree to lowest degree. That's it. And then the other term is the leading coefficient. It is the coefficient of the term with the highest degree. So in example 3, we are going to write each polynomial in standard form and identify the leading coefficient. So our first polynomial that we need to write in standard form is going to be 20x minus 4x cubed plus 2 minus x squared. So to write it in standard form, we need to first identify which term has the highest degree. And that's going to be this negative 4x to the third. So we're going to write that first, minus 4x to the third. And once we do that, we can ignore that term. We're then going to look at which term has the next highest degree. And that's going to be this minus x squared. So we're going to write minus x squared. And once we do that, we can ignore that part. And we're going to keep repeating this process until we run out of terms. Is going to be negative 4x cubed minus x squared plus 20x plus 2. Leading coefficient is the number in front of that first term with the highest degree. So a leading coefficient is going to be negative 4. So we've got that, and we've got our polynomial in standard form. Let's look at one more before we move on. We're going to have y to the third plus y to the fifth plus 4y. Well, to write this in standard form, we're going to take the term with the highest degree, highest power, and write that first. And that's going to be the y to the fifth. Now the term with the next highest power is y to the third, and the next highest is 4y. So standard form, we're going to have y to the fifth plus y to the third plus 4y. With a leading coefficient, there is one. It's going to be the number 1. So some polynomials do have special names. So first, let's look at the names based on degree. So if we have degree and name, if we have a polynomial with a degree of 0, we just call that a constant polynomial. If the degree is 1, the polynomial is called a linear polynomial. Degree is 2, we call that a quadratic. Degree of 3, we call that cubic. Fourth degree we call quartic. Fifth degree we call quintic. And then 6 degrees or more, we call them 6th degree, if it's a 6, 7th degree if it's 7, or we can generalize it and just call it nth degree. So that's how we name polynomials based off their degree. How do we name them based off of the number of terms? Because that's another way. There's not as many names for this. If we have one term, we've already defined that as a monomial. If they've got 2 terms, we use the word binomial. And 3 terms we call trinomial. And anything that's 4 or more, we just call a polynomial. No special names for anything above a 4th degree, or 4 terms. We are going to classify each polynomial based on its degree and number of terms. So, Our first polynomial that we're going to look at, having to classify, is going to be 5x minus 6. So with this, we have a degree of 1, and we have 2 terms. So if we're going to name this, we're going to call it a linear binomial. So in this second one, we're going to have y squared plus y plus 4. And here we have a degree of 2, and we've got 3 terms. So we're going to call this a quadratic trinomial. Let's look at one more. We're going to have 6x to the 7 plus 9x squared minus x plus 3. We've got a degree of 7, and we've got 4 terms. So this is a 7th degree polynomial. And that is it. So let's look at one last example. It's going to be a word problem. It states a firework is launched from a platform 6 feet above the ground at a speed of 200 feet per second. The firework has a 5-second fuse. The height of the firework is given by the polynomial -16 t to the power of 2. I'm going to have to write this one for you. -16 t to the power of 2 plus 200t plus 6, where t is the time in seconds. We need to know how high will the firework be when it explodes. And since the fuse is a 5-second fuse, we're looking for what's the value when t equals 5, because it will take 5 seconds for it to explode. So what we're going to do, we're just going to take 5 and put it into our polynomial for t. -16 times 5 to the power of 2 plus 200 times 5 plus 6. I would say go ahead, use a calculator to do this. If you don't, you're going to end up going -16 times 25 plus 1,000 plus 6, and again, calculator, use it. Otherwise you're going to get -400 plus 1,000 plus 6, which in the end is going to equal 606 feet. So the firework will be 606 feet above the ground. And that wraps our lesson up.